In this video, we're going to try and work out the volume of this bullet here. Okay, so let's start out with our square root of x graph. So this is our square root of x graph. The aim here is to split this graph up into millions of these disks. So the thickness of this disk here is dx here. So the aim here is to split this up into millions of these disks, and then sum up all the volumes, and then that will give us the volume of a bullet. Let's say our bullet is of length, let's say from 0 to 8. So the aim here is to split this up into millions of these disks and then sum up all the volumes. So let's go back one step. So normally when we work out the area of this square root of x, we would sum up all the rectangles from 0 to let's say from 0 to let's say 8. Okay, so the aim here is to sum up all the rectangles here. Let's just zoom into one random rectangle here. So the thickness of this rectangle here is dx. So normally what to work out the area of this whole thing here, normally to work out the area, we in effect are summing up all the rectangles here. So the height of this rectangle here is f of x, and then we would times it with the width of this thing here. So this width here is delta x. So we would times it with this. So in effect, what we're doing is we're summing up all the rectangles. But then we use the fundamental theorem of calculus 1 to be able to jump from here to just working this out. 0, 8, f of x, and then dx here. So in effect, to work out this area here, in effect what we're doing is we're summing up all the rectangles. But then by using the fundamental theorem of calculus 1, we would then use this to evaluate this, because the fundamental theorem of calculus 1 allows us to do that. But in order for us to fully understand the fundamental theorem of calculus 1, we would use the fundamental theorem of calculus 2. So we would use the fundamental theorem of calculus 2 to prove the fundamental theorem of calculus 1. And then from the fundamental theorem of calculus 1, rather than working this out, the fundamental theorem of calculus 1 allows us to use this in order to work out this. Okay? But the thing is, the fundamental theorem of calculus 2 really, in effect, it's the fundamental theorem of calculus 2 is really, in effect, someone noticing there's a connection between the area underneath a function and the function itself. Okay, so the whole basis of the fundamental theorem of calculus 2 is that there's some sort of connection between the area and the function itself. And then in order for us to understand this, remember we had to zoom into this. Okay, so let's say we've got a different function, a complicated one like this. So the area of this rectangle here, the true area of this rectangle, is trapped in between the lowest possible and the highest possible. So it took us a lot of work. We needed to understand this, and remember the c of x here. As this delta x tends to 0, this f of c becomes f of x, and we've covered all this in the past. The point here is that this thing here allows us to understand the fundamental theorem of calculus 2. The fundamental theorem of calculus 2 allows us to develop the fundamental theorem of calculus 1. And then the fundamental theorem of calculus 1 allows us to evaluate this by using this. Okay, so now so we would sum up this area by just jumping to this 0 to let's say 8 of f of x dx here. So normally, in effect, what we would normally do is actually this, summing up all the rectangles here. But rather than using this, we would use this. Okay, so now using the same principle here to work out the volume of this bullet, we are going to work out. I will continue in the next video actually. I will continue in the next video.